today we are going to discuss about the properties of steam. So we are going to define the various properties of the steam and we are going to learn the various definitions with the help of temperature, enthalpy, gas. So if we are able to understand this, we can easily write all the definitions. There is no need to mark. Okay. So let me just a fast recap. So what is this? Temperature, enthalpy diagram. Yes. So this is what we did in the previous class. So I am going to explain once again. So what acts in the position A? What is the position A? Let us consider 1 kg of water in a cylinder. Right? 1 kg of water in a cylinder which is having a frictionless piston at 0 degree Celsius. And a constant weight is applied on the piston so that throughout the experiment same pressure will be applied. So now I am going to supply the heat. What happens to the temperature of the water? The temperature of the water is going to increase. So that can be represented in a temperature enthalpy diagram like this, 0.8. So the temperature is going to increase. Not only the temperature, the enthalpy is also going to increase. At certain point of time, what happens? The water is going to boil. That point is represented in the temperature enthalpy diagram as point B. The temperature at that point is called as saturation temperature. That is represented as T. Yes, saturation temperature. Are you able to understand? Now, still I am going to supply the heat. What happens? Now, the temperature is not going to increase. Whatever the water particles are there, it is going to start converting into gas. So there will be an increase in enthalpy. There will be increase in the enthalpy. But the temperature remains same. Whatever the heat is supplied, that will be utilized to convert the water particles to vapor. At certain point of time, what happens? All the water particles is converted into vapor particles. That point is represented as C in the temperature enthalpy diagram, and that point of steam is called as dry steam. At which temperature? Saturation temperature. Right? The temperature remains same. That is the saturation temperature, but there will be no water particles in it. So that we are going to call as what? Dry steam. So now what happens? Still I am going to supply the heat. Now what happens? The temperature of the steam is going to increase. Any temperature of the steam above the saturation temperature is called as superheated steam. At temperature, at any temperature. So that we are going to call as what? T soup. That is the superheated steam. That point is represented as B. So this is what we did in the previous class. So now, based on this, now we are going to learn that all different definitions. So definitions we are going to learn. So between A and B, what will be the condition of water, whether it is in a liquid state, vapor state, or what? Liquid, right? So this here it will be liquid. So here it will be between B and C. It's a combination. It's a two-phase mixture, right? It is a two-phase mixture of water particles as well as vapor. So it will be water plus vapor. So next, this we are going to call as superheat. This is the superheat region. Okay, so the temperature of the steam will be above the saturation temperature. That we are going to call as superheated steam. So now definitions. So first thing we should know the definitions of different types of steam. types of steams there. How many types of steams are there? The first one is wet steam. Second one is dry steam. Third one is super heated steam. So you should know the definitions of what is the meaning of wet steam, what is the meaning of dry steam, what is the meaning of super heated steam. Can anyone tell me what is it without looking into the book? So I will tell you the definition of wet steam. It is the steam, the two-phase mixture of water particles and vapor particles at the given saturation, temperature and pressure is called as wet steam. I will repeat once again. Two-phase mixture of water particles and vapor particles. At which temperature? At saturation. At a given constant pressure is called as what? Wet steam. Is it clear? So just by looking at the sketch you can tell me wet steam means what between V and C. So the definition means two-phase mixture of water particles and vapor particles at a saturation temperature and at a given pressure, at a given constant pressure is called as what? Wet steam. Easy. So just by looking in the sketch you have to tell me. Okay. So next one what? Dry steam. Okay. The steam, dry steam is what? Which point? Point C. So if you explain the point C, so that will be the definition of what? Dry steam. The steam with no water particles in it. Okay. The steam with no water particles in it. At which temperature? Saturation temperature. At a given constant pressure is called as what? Dry steam. Is it not possible with the sketch? Do I need to dictate the notes? No, right? So what is the dry steam? Steam with no water particles in it. At which temperature? Saturation. At a given constant pressure. So that we are going to call as what? Dry steam. Okay. Now let us come to the superheated steam. The steam above the saturation temperature. Okay. The steam above the saturation temperature with no water particles in it. So that we are going to call as what? Superheated steam. Okay. So if we are saying the steam above the saturation temperatures, that means so that itself is a superheated steam. Okay, I will repeat once again. The steam above the saturation temperature, above the saturation temperature at a given superheated temperature, at a given constant pressure. So that we are going to call as what? Superheated steam. Is it clear? So these are the definitions of different types of steam. So next comes is the dryness fraction. The fourth one is dryness fraction. So what it is the name itself is telling is a dryness. Okay, dryness fraction. So that means it is going to tell the quality of the wet steam. It is going to tell the quality of wet steam. So how much percentage of the steam is dry? Okay. So dryness fraction, it is the ratio of mass of dry steam. So that is represented as mg, mass of dry steam to the mass of wet steam, mg by mf. Why it is mg by mf? What is the meaning of dry steam? Sorry, wet steam. Water particles plus vapor. So that's why it will be mg plus mf. So mg represents mass of vapor plus mf means mass of water. So that together it is called as wet steam. Is Is it clear? So this is what we are going to call as dryness fraction. So shall we repeat once again? So dryness fraction is a ratio of mass of dry stream by mass of known quantity of wet stream. Or you can say it is a ratio of vapor particles, mass of vapor particles to the mass of known quantity of wet stream. So that we are going to call as what? Dryness fraction. Is it clear? Now let us come to the enthalpy. What is that? Enthalpy. Enthalpy of water. Enthalpy of water or latent heat of water or sensible heat. So these are the different definitions are there. What is that? Enthalpy of water or latent heat of water or sensible heat. So what is sensible heat? That can be represented in the temperature enthalpy diagram. So this is the HF. HF. Sensible heat or enthalpy of water, okay, or latent heat of water or sensible heat. So that is represented as what? Can anyone able to try to explain the definition of enthalpy of water or sensible heat of water? Shall I repeat? I will explain you once. I hope the remaining definitions you have to generate by yourself. Okay. So what is sensible heat or enthalpy of water? Amount of heat required to convert 1 kg of water at 0 degrees Celsius to 1 kg of water at saturation temperature at a given pressure is called as what? Enthalpy of water or latent heat of water or sensible heat. Okay, then graph what I from A to B. So amount of heat required to convert. So from A to B. So what is the meaning of A? 1 kg of water at 0 degrees to 1 kg of water at saturation at a given constant. So that we are going to call as what? HF or sensible heat. So now HFG. What is the meaning of HFG? Latent heat of evaporation or enthalpy of evaporation. Can anyone try to explain the definition? What is the definition of HFG? Try ಮಾಡ್ತೀರಾ? Last time ಕೊಡ್ತೀನಿ. Okay. So what is the definition? Heat from B to C. What is B? Amount of heat required to convert 1 kg of water at saturation temperature to 1 kg of dry stream at the same saturation temperature at a given constant temperature. So that we are going to call as what? Latent heat of evaporation or enthalpy of evaporation. So next there is a term called as superheat. Superheat. What is the meaning of superheat? From C to D. Amount of heat required to convert 1 kg of dry stream at saturation temperature to 1 kg of superheated stream at the given superheated temperature at a constant pressure is called as what? Superheat or enthalpy of superheat. Is it clear? So I will repeat once again. Enthalpy of superheat or superheat. Amount of heat required to convert 1 kg of water, 1 kg of rice at enthalpy of superheat. So next, so there is another definition called as sixth one. What is that? Superheat. Enthalpy of superheat. Another definition is there. Degree of superheat. Degree of superheat. So it is the difference in temperature of superheated temperature and saturation temperature. So that we are going to call as what? Degree of superheat. Okay. So here I am going to pause for 5 minutes. Kindly recall the definitions and try to reproduce the definition in your notes. Afterwards, we will continue. Is that okay? Okay, so please kindly make a note of it. Dryness fraction is represented as x. So the value of the x is ranges between 0 and 1. So if the dryness fraction, the x value is equal to 0, what is the meaning of that? So we are at the point B. So point B. So if x is equal to 1, what is the meaning of that? We are at the point C. That means the complete steam is dry steam. If x is equal to 1, the steam is a dry steam. So in between this, it may vary from 0.1 to 0.2, 0.3, 0.4, 0.5. So what is the meaning of 0.9? X is equal to 0.9. So that means we are somewhere here. So that means 90% of the given steam is dry. Remaining 10% is wet. That means remaining 10% is water particles and 90% is vapor particles. So that is the meaning of dryness. It is going to tell you the amount of dry steam present in the given quantity of wet steam. Is it clear? So that is what the dryness fraction. So now we have to define another few definitions. That is H. Enthalpy of wet steam. In some textbook it is represented as H, or in some other textbooks it is represented as HW. Okay, HW. So that means in between B and C. So the formula will be HF, see HF plus X into HF. So in between B and C, right? In between B and C, what we have? HF. So enthalpy of wet steam. It is the amount of heat required to convert 1 kg of water from 0 degrees Celsius to 1 kg of wet steam at saturation temperature at a given dryness fraction. At a given dryness fraction at a constant pressure is called as what? Enthalpy of wet steam. In between B and C. Is it clear? I'll repeat once again. Amount of heat required to convert 1 kg of water from 0 degrees Celsius to 1 kg of wet steam. At which temperature? Of a given dryness fraction is called as what? Enthalpy of wet steam. Now, there is another definition. Enthalpy of dry saturated steam. That is represented as Hg. So, can you be able to tell me the formula of Hg? Just by looking into the temperature enthalpy diagram, you can tell me the formula for Hg. What is that? HF plus HF. Correct? Amount of heat required to convert 1 kg of water from 0 degrees Celsius to at saturation temperature at given constant pressure is called as what? Enthalpy of Dryness. Okay. Now, amount of superheat. So the definition for amount of superheat we already know. So there is a formula that is CPS T soup minus PS. Okay. Amount of superheat or enthalpy of superheat is given by formula CPS into T soup minus PS. What is the meaning of CPS? Means specific heat. It is a specific heat into what is this? T soup minus TS means what? Degree of superheat. So CPS means specific heat into degree of superheat. So that is going to give the enthalpy of superheat. So there is a difference between enthalpy of superheated steam and enthalpy of superheat. What is the meaning of enthalpy of superheated steam? Consider from A to B. So that is called as what? Enthalpy of superheated steam. What is the definition? Amount of heat required to convert 1 kg of water at 0 degrees Celsius to 1 kg of superheated steam at the given superheated temperature at a constant pressure is called as enthalpy of superheated steam. So the formula for the enthalpy of superheated steam H soup is equal to Hg. So that means A to C plus, what is plus? CPS T soup minus okay. So these are the various definitions that might be asked in your internals and examinations. Okay, so earlier syllabus there were problems are there related to this. So since number of credits has been reduced, so the problem part has been removed. Only the theoretical part and definitions are there for your internals and examinations. Okay, so just if you understand this temperature enthalpy diagram, you can easily write all the definitions. If you try to mug up the things, so somewhere the other way you are going to forget. Is it clear? So this is about the temperature enthalpy diagram. From the temperature enthalpy diagram, how we can know the properties of. I hope you understood.